Mu Sigma operates as a continuous service as a software company. What is continuous service as a software? This video is about explaining that concept. I'm going to share some slides with you as I talk to you about this. What is continuous service as a software? To better understand this concept, what we thought is that we will go through a series of question and answer sessions which have been laid out in a way to introduce you to some concepts that you're familiar with, but use that to build upon some concepts that you may not be yet familiar with. So the first question I want to ask is, what's the difference between systems of execution and systems of exploration? A system of execution is one which is about automating, activities for a specific set of tasks. It's about automating for the how. A system of exploration, to a large extent, is answering, questions like why something is happening now, what's next, so on and so forth. Building software for your accounts payable system is a system of execution. Building a collaborative planning, forecasting, and replenishment tool, which continuously is inquiring about the state of your business and how your business is evolving, is a system of exploration. We're going to make the case to you in a bit that the world is evolving towards systems of exploration relative to systems of execution. But before we do that, let's understand the difference better. If you were to look at the truth, why is all the explainable things plus the unexplainable things, all of the knowledge that we have plus everything else, which I would call ignorance. So if you're a fan of regression equations like me, y equal to f of x plus e. In the world that we lived in before, we were operating with the paradigm that E term, the error term, the anomaly term is a bad thing and you got to minimize it. So concepts like Six Sigma are based on minimizing the E term. Today, we are living in a world where we want to constantly learn from that E term. And that becomes the E term, the anomaly term becomes a zone of learning. In the systems of execution, the E term is surely bad. In the systems of exploration, the E term could actually be good. So systems of execution are typically task-focused, generating stable and predictable output, whereas systems of exploration are very much experimentation focused. As long as you can get to a place where your cost per question is lower, you can do more, you can ask more questions at a lower cost of time and cost of money, you can increase your curiosity quotient. Systems of execution are designed for efficiency, scalability, and standardization. Systems of exploration are designed for creating optionality and flexibility. In a world which is going to only become more and more uncertain and more unpredictable, organizations that are producers of optionality are going to win more than organizations which don't produce enough optionality. The best answer to uncertainty is optionality. So net system of execution evolved in a world which had lower entropy and a lesser connected problem universe. Guess where we are? We are living in a world of higher and higher entropy. And the problem space, the problem universe is hyperconnected right now. So that is a good segue to the next question that we want to answer. What is a hyperconnected problem universe? This is a concept that we have been trying to understand for more than a decade right now at Mu Sigma. And this is probably something we're very proud of, to come up with a very original way of thinking about the problem universe and why it's hyperconnected and how one should be thinking about that. So if you were to look at the problem space and you represent it in two dimensions. One is how, and when I say problem space, I mean problem and solution interactions too. How frequently the problems occur, and the how much impact, this if you solve that problem, a single instance of that solution makes for you. So when you look at this matrix on the bottom left-hand side corner, where you have less frequency and less impact per problem solution interaction, you have the barren desert of low return. You don't care about solving for those problems. On the topmost right-hand side, everybody wants to solve for those problems for obvious reasons. It occurs a lot, and the impact from solving it is also a lot. And we call it the fertile land of disproportionate return. I'm going to make a case to you that the fertile land of disproportionate return is not actually what it claims to be. But before I do that, we have to understand the land in between, which I call the river of reasonable return. The number of problems in your organization are highly weighted towards the river of reasonable return. Your world is not one or two big problems, but many, 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 many small problems that are actually interacting with each other. But we don't see these problem spaces as interactions. We see them separately as entities. And on the top left-hand side corner, high frequency, low impact, you want to use software and algorithms to be solving for it. On the bottom right-hand side, you have to be heuristic, because these occur in less frequency, but they have tremendous amount of impact. So the services paradigm is very good for the bottom right-hand side. On the top left-hand side, the software paradigm is very useful. So the currents are algorithmic to heuristic as you go from top to bottom, and heuristic to algorithmic on the other side. But warm currents meet cold currents in between, and the richest problem space occurs right in between. What we are saying is that understanding these problems separately as separate stars allow you to think about it as projects, but programs evolve as you see the interactions between them, and you can make them constellations. So the fertile land of disproportionate return emerge, from these interactions. If you don't see it that way, what you have there is a fertile land of disappointing return. So appreciating problem solving as interactions is going to become very, very important. Now, what is the nature of the hyperconnected problem universe? I've listed about 10 points here. I'll go one after the other. They are all extremely granular. The problem space with more and more information is becoming more and more granular, more and more smaller and atomic. Each of these atoms are different from the other ones. Problem spaces, because of we are living in a world of higher information, they have a tendency to have more heterogeneity in them. There's nonlinear effects as these interactions take place, because you start seeing exponential impact at a certain level of interactions. The world is becoming more probabilistic. It is physics moved from a Newtonian deterministic world to a quantum probabilistic world. Same way, business is also going from a very deterministic world to a probabilistic world. Things are all moving quickly. Things are all moving constantly because of various reasons, both supply and demand side, because of technology, so on and so forth. There's a lot of dynamism in that world. Interdependent. Things are interdependent with each other, And there's a cause and effect among these problem spaces, among these individual dots as they are interacting with each other. They're all learning from each other. They're creating feedback loops. They have to be adaptive as you think about this. There's an emergent phenomena. The fertile land of disproportionate return emerges from the interactions between all of these problems. There is higher uncertainty in both what to do and how to do as the hyperconnected problem space increases the complexity in your ecosystem. So the analysis of the problem space leads us to the conclusion that problem solving as interactions over entities is necessary in a hyperconnected problem space. Problem solving as separate entities is you took one problem at a time, you solved it, and then you brought everything together at the end. Problem solving as interactions is that you're seeing the problem space as interconnected right during the problem definition space. You're not solving for planning separately, from forecasting separately, from replenishment, but you're looking as interactions between collaborative planning, forecasting, and replenishment, and solving for it all together. In all of this, what we are seeing is that the reality representation gap widens. People everywhere, every company that we go to, we get this perspective: our data is not clean, our data is not clean. It is the natural law of data to only become more and more unclean, because it is a property inside reality representation. So you have the reality, which is constantly evolving, and you have the representation of that reality, which is learning from that reality and representing itself in information systems. This reality representation gap is constantly increasing. So it is increasing because of higher volatility and ambiguity. It is increasing because of higher complexity, higher ambiguity. It is increasing because of over-connectivity. It is increasing because of technology changes. Reality representation gap can only increase, which means that the quality of data in your organization can only become worse and worse and worse in the future. So your ability to deal with this aspect of data getting worsening is going to be a key a property of how well you do in building systems of exploration. But before I go there, I want to ask this question: why will the world need more systems of exploration relative to systems of execution? Understanding this, the origin of systems of exploration is going to become very, very important. What I want to start with is by making the perspective that that connectivity between simple solutions of yesterday lead to complex problems of today. You may have innocently, come up with some solutions to solve a bunch of problems, but soon that becomes features for the complex problems of today. We probably, were trying to solve a whole bunch of simple things of distribution when we came up with internet as a distribution channel, but soon it has become a way of life for us. And every problem that we have needs this as a feature in today's ways of thinking. So simple solutions from yesterday, when they start interacting with each other, create complex problems of today. So the second thing is the problem space is continuously shifting. We talked about the river of reasonable return. There are so many reasons, so many angles from which these problems could interact with each other, and the river of reasonable return as a canvas for holding those problems is continuously shifting. There is increasing uncertainty in the world, and it makes it harder for organizations to be more prepared for unpredictability. Now, you have organizations who have a culture of wanting predictability. You have their financial models which operate on a quarter-by-quarter basis, and they have investors who are looking at measuring these organizations on a quarter-by-quarter basis. And that makes it harder for these organizations to develop capabilities that build for them to be thriving in unpredictability. So at best, they are looking to be resilient, and they're not going towards becoming anti-fragile. So being more prepared for unpredictability requires these organizations to have become producers of optionality. How do you become producers of optionality? You achieve it by having a higher curiosity quotient, having a lower cost per question. To do that, you have to be able to industrialize the exploration process. Like we industrialized the execution process, we have to industrialize the exploration process. And that means that you're going to need you're going to make new kinds of food, but you're also going to need a new kitchen. The differentiation your organization will provide to its investors from exploration will matter much more than differentiation in execution. Your alpha will come from exploration. Your execution prowess can at best be beta because it'll get copied very quickly. So to do that, you have to understand where we came from our current problem-solving paradigms, and where we are going to go based on where we came from. So first is the services-only paradigm, extremely flexible, not very scalable because it's people-dependent, and not sustainable for that very reason. It's extremely people-dependent. You have the software paradigm, not very flexible. You have to solve a certain problem, but it's extremely scalable. And as the world changes into newer and newer problems, and as you get into this hyper-connected problem space, it's not sustainable because you're trying to solve different problems and not the same problem more times. And then you have the software as a service paradigm, which built on the software paradigm, but a little bit more sustainable, despite the fact that it had the problems associated with software paradigm. Again, it solves for one particular problem, but very scalable and very sustainable. Let's understand this a little better. What are the attributes of each of these paradigms? So let's start with the services paradigm. Extremely flexible, adaptive, benefits from human judgment, suitable for high impact, low frequency problems. So wonderful. And what are the negative attributes? Not very scalable, dependency on experts, does not cater well to high frequency, low impact zone in the river of reasonable return. So net, you have old school management consulting in this paradigm, right? And then you have software companies came up with solutions for particular problems. You have a supply chain software, you have a revenue management software, you have a software for documenting documentation like Microsoft Word. All of these are solving for a particular problem. The positive attributes: very scalable and reusable, consistent, high standardization for the solutions, suitable for low impact, high frequency problem spaces. So it's wonderful to do it again and again and again. You want to solve for it. But the negative attributes are, if the problems changes, of the features of the problem changes, and therefore the features of the solution will change. If the nature of the problem changes, it's not very flexible and adaptable because software is built for certain functional and technical specifications. And as that changes, it doesn't change as fast. Does not cater well to the low frequency, high impact problem zone in the river of reasonable return. So, because of all of this, we had this. Both people understood that either software alone or services alone is not going to be enough. And the next best thing that they came up with was software as a service. And why did it become interesting? For the simple reason that it allowed the solution, the consumer to not have to worry about building it and maintaining the software. Allowed for quick deployment, continuous updates, simplified interoperability. And last but not the least, it helped you go from CapEx to OpEx, where you're just looking at it as a service and consuming it. But all of these above paradigms are failing in what we call the hyper-connected problem universe of today. The hyper-connected problem universe, where the river of reasonable return becomes the most important canvas that you have to focus on. So we are no more just building products and services as separate entities today in this new world. We are building experiences which emerge through these interactions that we have. So building experiences requires a different way of thinking than building products and services. Systems of exploration are therefore going to be more necessary in a hyper-connected problem universe, and they have to cater for economies of scale, which is you've got to do more of the same, economies of scope, which is you have to do different things as you do more, and economies of speed, which you have to do it faster and faster and faster, because the technologies that we live in today allow people to have experiences, and a lag will mean that their experience is negatively impacted. So the new world necessitates agility, but with flexibility and scalability. So the consumers want all of it, right? In this hyper-competitive space, in a hyper-competitive problem universe. However, the existing solution paradigms make scalability and flexibility mutually exclusive. The software paradigm gives you one, the services paradigm gives you another. While this is a very important point, while solutions are required to thrive in uncertainty, the current problem-solving paradigms seek predictability, right? So you want your solutions to do very well in unpredictable worlds, but your methods of problem solving are still wired for predictability. The future needs them to seek variance. The hyper-connected problem universe craves for anti-fragile solutions that produce optionality. So these new systems of explorations will love Sigma, and they will not hate it, and they will be producers of optionality. So all of these are reasons why we believe that the time is ripe for a new paradigm, which is not software, not services, not software as a service. So what we propose is something we call service as a software paradigm, which is very apt for a hyper-connected problem universe. Now, for every solution, you have three parts. You have the problem definition, you have the solution design and development, and you have operationalization. For each of these things, we have to understand that because the world is changing constantly, the problem definition has to be flexible. Because it has to be flexible, it has to be services oriented. The solution design and development have to be scalable and even agile, maybe to some extent, and therefore products make a lot of sense. Software makes a lot of sense for solution design and development. Operationalization again needs scale flexibility, because you don't know where you are going to deploy your solution. It can be in a different geography, it can be in a different distribution channel. So therefore you again go back to flexibility, and therefore you again go back to services. So the whole solution has to be maximized for agility while optimizing flexibility and scalability. Therefore, service as a software. Your problem definition services, your solution design and development software, again, operationalization services. But we say that it has to not just stop there, it has to be continuous. What we mean by that is it is service as a software, as a service, as a software, as a service, as a software, because the problem space of yesterday becomes the solution space of today. The dynamic nature of problem solution interaction requires the presence of strong feedback loops that facilitate learning, right? A world of algorithms will differentiate organizations on how anti-fragile their response to stress is, how much you thrive because of stress. And you're not just looking at being resilient, you are looking at getting better than the next person because of that stress. And in such a world, all work is going to become network. What do I mean by that? There's work of the past, and that's your knowledge repository. They have to go from being databases to becoming knowledge graphs, which are the network form of databases. Work of the present is all learning, and that has to go from individual questions to having an inquiry engine, which is question networks. So building inquiry engines, which are question networks, is going to become very, very important for the future. And last but not the least, work of the future, which is all your insights came from either dashboards or reports or predictive models and machine learning and all the good stuff. They have to become algorithms, which are network forms of the same. So what is required to implement, continuous services software? This is key. We've thought, long and hard about this, and we came up with the following features, which are going to be very, very necessary for a world of continuous services as software. And we've also developed an implementation paradigm for it called the Akashic architecture. But what is the Akashic architecture based on? What does continuous services as software need? First thing is, from a mindset perspective, you need a mindset of abundance. You can't have a mindset of scarcity. And it has to be fueled by a culture of adventure, not by a culture of fear. Adventure is fear having fun. So you need a culture of adventure and a mindset of abundance. Second thing is, you have to have a skill set, not just based on coming up with answers, but also asking fantastic questions and deep questions. So you need an inquiry engine, above and beyond the signal engine. Building good inquiry engines is going to become very, very important. You need last thing is that you need a holistic interaction-based problem-solving ecosystem. You need a kitchen, which is new for this new world. It's going to have an inquiry engine. What we mean by that is ontologies, knowledge graphs, question networks, decision supply chains. Ontologies are going to become very, very important in converting your natural language to a programming language. And doing it without any human intervention is going to be very, very important as natural language goes to, programming language. You need an intuition builder for the present context, to build intuition from the omnipresent field of intelligence. There is a field of intelligence, you might even call it wisdom, but there's a field of intelligence you can tap into, which is not, present in the current context, but is present when you look at it cross-industry and cross-functional. How do you tap into that field of, the field of wisdom, field of intelligence, and come up with better intuitions? Once you have a good inquiry engine and you have ontologies in place, having LLMs will allow you to tap into that field of we call that field Akasa repository, and we'll show you in our implementation how we have implemented this intuition builder. The future is no more going to be about intelligence. Intelligence will be commoditized because the machines will be working on it. Human beings are going to bring intuition to the table, and how well they bring intuition to the table is going to be the differentiator. And last but not the least, all of this has to be done at a speed which can only happen by implementing, agentic AI, where you have personas of different human personalities, and you have a dialoguing mechanism. And I intentionally say dialoguing and not debate and discussion, but dialogue. A path to truth, is a dialogue. And that happens, at a speed which only machines can deliver for us. And that's going to be very, very important in building these new systems of exploration. So I'm very excited about this concept of continuous service as a software. And we will have a separate video created for the implementation of this using what we call our Akashic architecture and Akasa repository. So hope you will be interested enough to, based on what I just shared with you, to go and look that up. Thank you for your time today.
Ooh.